Welcome to Shamford. I'm Jessa, and here we discuss all things 3D printing. We have a couple of drills on the workbench today, and these are the ones I use indoors. They're a little bit smaller than the ones I use in the garage. They're 18 volts. Anyway, they get used inside, especially this one mostly stays on the workbench. So I was thinking between the fact that this one only gets used here and that I sometimes forget to charge my batteries, I thought I'd make an AC adapter for this drill. By the way, this drill on the right goes through a much higher power surges. Given the right battery, it goes up to 800 watts. And I don't want to invest in such a big transformer, or I don't even have wires for that anyway. So for this video, we'll focus on the one on the left. This one needs about 3 to 4 amps with no load and a little bit more with a little bit of load, but all I'm doing on the workbench is maybe drilling some plastic or tightening some screws and whatnot. And I've already done some experiments. This model is from Thingiverse. It's a 3-part print. And the top part, you can see I've got a couple of spade connectors embedded with wires sticking out. And this 10 kilo ohm resistor is what tricks the drill to think that it's a legit battery. So I've done what I've had to do to make the experiments work, like drilling holes through the parts. Some clips had broken off while I was trying to fit the parts together, so that needs to be fixed. My next step is to make those holes in the model rather than trying to drill in real life physically, and possibly combine these parts together so I don't have to worry about the clips breaking off. And that is possible because I won't be installing battery cells in this enclosure. I'm just feeding my wires through. All right, enough said. Let's jump on the computer. Okay, we're in the slicer, and let me walk you through what I plan to do. The bottom piece I will not be reprinting because it's in a good shape still. I didn't break it, so that's good. Well, we can remove that from the plate. So that leaves us with these two pieces. And let me put them together and move each piece where they need to be, roughly. And one thing I want to say is that if something looks good on the screen, it's probably good enough, because your printer, or my printer anyway, if you think about it, is never that precise. The layer height is only 0.2 mil in most cases. So I tend to be a little less precise, knowing that it doesn't matter in the end. I'm going to change the color of this top piece so I can see a little bit better. Yeah, so that should be good. Looks good enough from the top and looks, again, good enough from the side. So I'm happy with that. So let me change the color back. Okay, now I need a cylinder as a negative part. I'm going to do a quick slice just to see if I'm on the right track. So a big hole through the bottom, and I have good access through the walls. And the other thing I have to do is change the size of this hole because it was a little too small for the spade connectors. So I'm going to do something like this. Okay, I know the dimensions are 8.3 and 3.3. That's the size I want. So again, doing a quick slice. Now the holes are larger, which is what I want. Okay, I've been staring at the model for a while, and I realize all of the contacts are concentrated here in this corner. So I actually don't need access through the walls. And the other thing is, if we do a quick slice here and As I go down the layers a little bit, there's a lot of outer walls, which makes the part stronger, and that's all good, but I don't think this is necessary and is only adding to the print time. So if I bring the window over, it's saying that the print time is roughly 2 hours. And I think we can shave that off a little bit. So yeah, let me go ahead and make those changes. All right, the changes have been made and we're down by 15 minutes, give or take. So that's good. And this is just for the model alone. We didn't even look at the time for the supports because I have the settings disabled, but I think we shaved off a few more minutes in supports as well. And one final adjustment I want to make is that this is where the resistor goes, and the tiny leg on the resistor is not making a great contact. So it is possible that the tool will cut in and out depending on how good of a contact it's making. So I have a couple spools of copper strips that I can use for this application. And I want to change the geometry a little bit to help the copper seat better in this cavity. What I'm trying to do is the copper strip will start over here and then it will sort of follow the contour of the sphere and it will end over here. So this entire area becomes the contact as opposed to a tiny little leg on the resistor. And judging by the size of the sphere that I just added, which is roughly 3 millimeters across, or sorry, 6 millimeters across, I think this cavity is maybe 5 or 5.5 millimeters wide, which is smaller than the copper strip that I have, but I can just cut it off with a pair of scissors, so no big deal. But one thing I do need is the ability to fold the copper strip over and attach it securely to the enclosure. So maybe I'm going to make a small slit over here so I can wrap around and put the remaining length in that cavity. I'm probably not doing a great job describing my plan, but it will become clear when I actually show it on the camera, so bear with me. All right, so there's my cutout. Let's see how that renders. So give it a quick slice. So the holes are bigger. There's the sphere that I added. I'm not sure how strong this is going to be because it's a little small bit over here. Maybe I'll make that a more square shape, but we'll do that in a minute. And the little slit that I just added. Okay, looking at the layer lines, I feel much better about this shape now compared to what we had before. So I'm gonna go ahead. And this corner sticks out a little bit, but it's easy enough to just shave it off with the knife. So I'm not gonna bother fixing it in software. And it just occurred to me, I think I might print this again in the future, and I don't want to go through this whole process again. So I'm going to do a test print, see if I like it, and if I do, then I'll use the Boolean operators to make all the modifications I made into a single STL. Because the negative parts that I've added, they don't necessarily transfer over to other slicers and things like that. And you never know, I might be using a different slicer in the future. So I do want to keep a compatible copy for the future. All right, the print is done. It's in my hand and it feels pretty solid. One thing I didn't realize until after was that when I added that cylinder, I didn't extend it all the way down, so it left a little gap here, and this little gap caused a 5-minute delay. So yeah, it'll be fixed in my final version, but just pointing it out. So there's a few things that need to happen. One, I need to solder a small segment of this copper strip onto one of the legs of the resistor, feed that through, and fold it over. Oh, I gotta shave that little bit off first, but that's minor. So after that's done, I gotta finish all the wiring work, although it's not that complicated. And lastly, I gotta get the power supply ready and think about the cable management. Right. A couple of thoughts after assembling everything. First, I'm not convinced that these clips on the sides are doing anything. When I push the battery in, I don't really feel anything engaging. I don't hear a click or anything like that. And what's really evident is that if I pull this out, it slides out. But you just saw there was quite a bit of resistance when I tried pulling it out. And all of that friction is coming from the spade connectors. And the other thing is that this copper strip is not held in place securely. It flaps and it's almost breaking off. Yeah, it just snapped. Now I'm going to need to find a way to reinforce it, either by using glue maybe, or something more mechanical. I'll think about that a little bit more. I've given some thoughts and I've decided against doing a reprint. I could make this whole thing smaller, knowing that this bottom 20% is not really necessary, and a bunch of other improvements, but yeah, I'm just feeling lazy today, so I'll try and fix up what I already have. So I think the only critical issue here is that this copper strip is too fragile. The clip's not engaging is not really a fatal issue. It's just not being used. So not the end of the world. This terminal technically is not something that causes arcing, for example, because it's just a sensor from the perspective of the tool, but it does control whether the tool needs to be on or off. So if the battery keeps cutting in and out because of a poor connection, then I can only imagine that's not good for the tool. And obviously it'd be super annoying to the user as well. So I've got a different roll of copper strip. This one is a little bit thicker than the one I used before. So hopefully this is a little bit more durable. And also, instead of having one end of the copper strip just hanging out on the exterior. I'm going to do a full circle and solder both ends on the inside. So it's well protected, there's less movement, and hopefully that makes it more strong. This one's a little more difficult to push in because, like I said, it's a little bit thicker than the last one. But we'll manage. Okay, here's a close-up for you. Let's fold it over. So this is what it's going to look like. The problem is that if I heat it up too much, the solder on the left will melt again, and that's not good. So I gotta be careful. All right, that's the end product. Let's give it a go. Yeah, I'm not so sure about this one. Maybe it will puncture eventually. We'll see. Yeah, I've been trying to solder these wires to this XT60 connector, and these are not taking solder at all. And I didn't think much about it before, but now I'm looking at it. This is silver, and I'm thinking probably aluminum, which explains why I had what looked like a cold joint earlier in the video when I soldered that resistor to the crimped connection. Anyway, I don't have a ton of alternatives right now, so I'm going to use these ferrule connectors to crimp the wires first, then solder them to the XT60. Okay, that could have been better, but I got it done anyway. So this end of the connector goes to the drill, and this end goes to the power supply. So let's give it a go. Okay, right off the bat, I see the LED light up. And when I hold the trigger, you'll see that it's showing 4 bars. I do want to cover a couple more topics like cable management and possibly a stress test, but this video is getting pretty long, so maybe we'll cut it right here and continue on in the next video. Thanks for watching, and I hope you got something out of this video. See you in the next one. Bye.